Hello students, welcome back. Today we'll study about absolute error, relative error and percentage error and numericals based on it. So before starting, what is an error? Okay, if I just write down error, then what is an error? Right? In simplest language, we can say error means mistake, right? Error means mistake, right? Just for example, if the length of this pen is 10 centimeter, and if you measure it to be 10.5 centimeter, that means you're making a mistake. That means you're making an error in the calculation. Same if you're measuring 9 centimeter, then also it's an error. Right? What's the error in the first case? 0.5. In the second case, 1. Right? In the first case, 0.5 centimeter. Second case, 1 centimeter. Right? In fact, minus 1. First case will be 0 minus 0.5. It will subtract it from the true value. So, in short, error means difference between measured value and true value, right? Error means difference between measured value and true value. So if this 10 centimeter, so whatever measurement you are making other than 10 centimeter will make an error. Okay, so now let's find out the three main terms: absolute error, relative error, and percentage error. Now, what is absolute error? Absolute error means magnitude of difference between true value and measured value. Okay, magnitude. Here the word magnitude means whether I am measuring 11 centimeter. We have taken the example of this pen, its length is 10 centimeter. Whether we are measuring it 11 centimeter or 9 centimeter. In both the case, the error will be 1 centimeter, right? In first case, if you take 10 minus 11, it will be minus 1. Second case, 10 minus 9, it will be plus 1. But when we take only the magnitude, right, means we are taking its absolute value, modular. Okay, we are taking its absolute value, that is absolute error. Okay, relative error. Okay. Now, what is relative error and why relative error is important? Let me make you understand. First, let me give you two examples. Two students, or let's say two boys, A and B. Clear? Both are going to the market. Okay? Let's say that their mother has sent them to purchase some sugar. Right? Both boys A and B, they are going to market to purchase some sugar. Now boy A, okay, when he comes back home, he brings 50 gram less sugar. Clear? Boy A, when he comes home, he brings 50 gram less sugar. And boy B, right, when he comes home, he brings 100 gram less sugar. Right? So what is the error of A? 50 gram. He didn't bring the quantity that he was asked. Even B. Okay, so A brings 50 gram less sugar, B brings 100 gram less sugar. Now, if I will ask you who has done a big mistake, right? Whose mistake is higher? Obviously, from this data, you will say that B has done higher mistake. Okay, but your answer will be wrong unless you will not get the complete data. Clear? B has brought 50 kg sugar less, but his total was, sorry, 50 gram. His total was 500 gram. Means A was told to bring 500 gram sugar, and from that he brought 50 gram less, right? B brought 100 gram less, but he was asked to bring 10 kg. 10 kg means 10,000 gram. So now whose mistake is higher? 50 out of 500. That means it is 1 by 10, okay, or 0.1 percentage. Multiply by 100 percentage. 100 by 10,000. That is 1 upon 100 or 0.01 percentage. So see, relative error, or let's take, we will calculate percent later on. Means what is the error? 1 out of 10, and this is 1 out of 100. Clear? So I will say it this as not 1%, 0.1%, this will be 0.1. Okay, that was my mistake. And this is 0.01. Clear? Now which whose error is higher? A. Right? Initially, it seems that B has done a big mistake, but now compared to them, A has done a big mistake. So, relative error is important because you have to compare that error with the true value. Then only you can justify that which error is higher relatively. Clear? So, what is relative error? It's the ratio of mean absolute error to true value. Okay? Mean absolute error to the true value. Clear? Now, what is mean absolute error? Suppose that you are, when you are given calculation, you are measuring the length of this pen for 5 times, and every time you make different error, right? Let's say in one case you make 0.5, second case 0.4, 0.6, 0.3, 0.2. So now every case the absolute error will be equal to 0.5, right? 0.3, 2.2. So take average, and that will be the mean absolute error. Okay, so relative error is ratio of mean absolute error to true value. Clear? And the last, percentage error. Percentage error. Percentage error means when relative error is taken in percent, it is percentage error. Okay, when relative error is taken in percent, it is percentage error. That means relative error multiplied by 100. Okay, The symbol for relative error we will be going to use is delta. Okay, so for percentage error, this will be delta into 100. Clear? Okay. So this was about absolute error, relative error, and percentage error. Just note down these three topics. Okay. I'm not going in detail here. When we will solve the numericals, just after this, at that time, we will I will explain you in detail. So just note it down. Okay, so now let's move ahead. If you have still not complete, then just pause the video and then complete it. Okay, now let's take one example. Okay, I will use the same example measuring the length of this pen. Okay, so now you are taking five measurement of this pen. Clear? Means you are asked that measure the length of the pen. You are measuring one time, noting it down. Second time, noting it down. Third time, noting it down. Fifth time, noting it down. Okay? But you don't know the true value. Okay? So let's take length. Okay? So your observation, I'm writing your observation 10.20, 10.15 centimeter, 10 point. You might be measuring with 1 year calipers. So its accurate precision is up to this digit. Okay, two digits of decimal. 10.13, 10.12, and let's take 9.07. Okay, so now this is your measurement. You're measuring it for 5 times and you are getting these five observations. Right? Now see, in this case, true value is not given. So what should you do? You should take the average. Okay? So I will write it down here. L bar. L bar means the average. Clear? So average of this will be taken as a true value in this case. So let's add it. So it's 10.20 plus 10.15 plus 10.13 plus 10.12 plus 9.07. It's 49.67. I will write down summation of L 49.67. Clear? How many values are there? N equal to 5. Right? So in L bar, we have to take average. So 49.67 upon N. So it's 49.67 upon 5. Let me calculate it. It's 9.934. So what we need to do, we need to take it in a round figure. Okay, we need to take it in a round figure. So I will take 9.93. Why do? See here, after decimal, I can measure up to two decimals. Clear? So my average value must be after decimal two values only, two digits only. So I'll take round figure. So this will be equal to 9.93. Okay, this is L bar. Clear? If it was greater than 5, then I would take 9.4. Okay, it's less than 5, so 3. What would you do if it is 5? Okay, that you will study later in this chapter only in significant figures. Then you have to check whether there is odd or even, and then you have to make the changes. Okay, that will study later in this chapter. So it's 9.93. This is the true value. Clear? So now I want delta L. Absolute. So I am taking absolute value of delta L. Means I will subtract it. I will not take minus if I get a negative answer. I will take modulus, that is absolute error. Okay. So now first 10.20 minus 9.93. This will be 0.27. 10.15 minus 9.93. It will be 0.22. 10.13 minus 9.93. It will be 0.20. 10.12 minus 9.93. 0.19. 9.07 minus 9.93. It will be 0.86, I would say. Clear? Actually, it will be minus 0.86, but as I am taking modulus, absolute error, so these are the absolute error in each step. Okay, let me confirm 10.20 minus 9.93, that will be 20 plus 7, 20.27. 10.15 minus 9.93, 15 plus 7, 0.22. 10.13 minus 9.93, 0.20. 10.12 minus 9.93, 12 plus 1, that is 0.19. 9.07 minus 9.93, that is, yeah, 0.86. Okay, so what is this? This we have taken as average true value, absolute error. Now, average absolute error. I will use delta L bar. Okay, so what will be the formula here? Summation of delta L upon N. Clear? So now let's write down this addition. Let me add this 0.27 plus 0.22 plus plus 19 plus it's 1.74, right? Summation of delta L is 1.74. So this will be equal to delta L bar 1.74 divided by 5 because we have measured 5 times. So let me calculate it. Divide 1.74 divided by 5. It will be 0.348. So I have to take two decimals. Remember, after decimal I make two digit. So what I will do, round figure 0.35. This is average absolute error. Clear? Now the next is relative error. For symbol is this delta L. Relative error. Okay, delta L. So what is delta L? This will be equal to average absolute error upon true value, right? Means error upon true value. So what is the error in relation to its true value? Clear? So this is average absolute error. This will be equal to 0.35. And what is the true value? 9.93. So let me calculate it. 0.35 divided by 9.93. 0.03524. Okay, so this is your answer. This is the relative error. Clear? The last, percentage error means you have to take relative error in percent. You have to write in percent, that is delta L into 100. Clear? I will use delta L bar. So this will be equal to 0.03524 into 100, 3.524 percentage. Round figure I will take 3.52%. Okay, so this is the percentage error. Clear? I'm repeating once again. What we had done, we had measured 5 times. So we had added it, summation of 5. For true value, total of all the values divided by the number 5. Because we have taken 5 observations. This is true value. Absolute error, subtract the true value and measured value. Okay, and take its absolute value, modulus. Clear? Average absolute error. Okay, average of this. So add all it, divide by 5. Clear? Now relative error, total average absolute error upon true value. 0.35 divided by 9.93. And percentage error multiply by 100. Clear? Now, how would be the length? The answer of the length written. The answer will be written as length is equal to, what is the true value? 9.93 plus minus 0.35 centimeter. Okay, the length is written as 9.93 plus minus 0.35 centimeter. Why I'm writing plus minus? Because this is the average absolute error. As we have taken absolute, we have also considered positive, negative, and taken modulus. So it can be plus 0.35 greater or plus 0.35 smaller. Clear? This is the answer in terms of absolute error. But if the question is asked, write down your answer in terms of percentage error. Okay, this is in terms of absolute error. But if the question is asked in terms of relative error, then at that time L will be equal to 9.93 plus, sorry, not relative, percentage error, plus minus 3.52 percentage centimeter. Clear? This is your answer in terms of absolute error. This is your answer in terms of percentage error. Clear? Remember, simple steps, list down all the measurement, it's average. Absolute error, subtract average and this. Okay, again, average of absolute error. Ratio of relative absolute error to the true value. Multiply by 100, you will get the percentage. Okay, percentage error. Clear? Just note down this example. Okay, students, so that's it for today. In our next video lecture, we'll solve some more examples based on this relative and percentage error. And also we'll solve numericals uh, based on this, but something other like if error in terms, sorry, if the measurement is given in terms of absolute error, and if you need to find out the relative error from this, then how would you find it out? So we'll solve some other sums based on errors. Okay, thank you.